So they start off adding rational numbers using the number line. And again, this is not something that you will necessarily use day to day. This is a visual representation so that when you start using the rules, you remember what we talked about. So when they use the number line to do this, you always start at 0. And your pluses and minuses just mean direction, okay? Just mean direction. And so we're going to start with something really simple that hopefully, all of you can do, right? We can do 3 plus 2 way back when we were in like first grade, kindergarten, whatever. But we're going to look at it on a number line so that when we throw in the negatives, it makes a little more sense, all right? And so when you use a number line to do addition, you start at 0. If you do not see a sign in front of the number, you assume it's positive. So that 3 is positive. So we're going to go 1, 2, 3. And then it says plus 3. That's also in the positive direction, 1, 2. And as we all know, 3 plus 2 equals 5. So this is number line. Like I said, it's not a practical use of addition and subtraction because that would take a long time to draw a number line every time you wanted to add 3 plus 2. But what it does is it gives you a picture so that when you start doing larger numbers and you're doing addition of negatives and positives, you start thinking, okay, I moved further in the positive direction than I did in the negative, but I ended up with a negative answer. Something's wrong. And so it gives your brain a way to second check what you did and see, did I do it right? And so like for this one, -1 plus -3, this is where I have students start to struggle because we start throwing in negative numbers. And so if I look at this one, I'm going to start at 0, just like I did. That's a -1. So -1 is going to move me in the left direction. 1. And then it says plus -3. I'm going to move in the negative direction again, 3. So 1, 2, 3. And we know that -1 plus -3 equals -4. All right? And so this is how you start thinking about positives and negatives. You start thinking about direction a little bit. And so from there, we move to just adding and subtracting. So if we look at this one, 2 plus 4, we all know what that answer is. What is 2 plus 4?
6.
It's 6. But on the number line, what directions am I moving? So 2, I'm moving positive, which is right. And then plus 4 is moving positive again. So that's why I end up with a +6 as my answer. All right. What about this one? What directions am I moving? Both, right? I'm moving left 2, right? And right 5. So which way did I move further? To the left or the right? To the right. So I moved to the positive. So this tells me I should have a positive answer here, right? Which is what you do. You end up with a +3. And if I do it on the number line, I go left 2. And then from that point, I go right 5. 1, 2, 3, 4, 5. And there we go. We know that it's +3. And so this is number line. Again, I'm not going to be like, hey, add all of these 10 numbers with a number line, right? That's not the point. The point is so that you start thinking about it as movement so that when you start using the rules, which is what we're about to do, you don't tell me that -2 plus 5 is like 7 or something like that. Because that doesn't make sense, right? I shouldn't go past 5 if I had a negative in there. So let's look at the rules. Here are the rules. All right? And they use absolute value here because you can kind of ignore the signs at first and then go from there. Let's say they have the same sign. They're either both positive or they're both negative. Now, these are the rules for adding, okay? The rules for adding. They're either both positive or both negative. All you have to do is add their absolute values, so whatever the numbers look like, and then you just keep the sign of what they both were, all right? So like the first example here, they have the same sign, right? I have a negative and a negative that I am adding, all right? So I am just going to add the 1 and the 3. What is 1 and 3? Very simple. It is 4. And then I'm going to say, well, they were both negative, so I'm going to apply that to my answer. You just keep the sign. Add them and keep the sign, all right, if they are the same. Now let's look at when you have different signs. This is what throws people off. Ignore the signs. Subtract the smaller from the larger, okay? It doesn't matter what order it's in, if it's addition, all right? Subtract the smaller from the larger, and then you are going to give your answer the sign of the larger absolute value, all right? So look at the next one. We have a positive 8 and a negative 3. Those very definitely have different signs. Remember, if there's nothing in front of it, it's positive, and I'm adding it to a negative, right? These are different signs. So for right now, I'm going to ignore it. I'm just going to subtract the smaller from the larger, right? What is 8 minus 3? 5. And then I'm going to go back and say, well, which one of these was the bigger absolute value? The 8 or the 3? 8. Is that one positive or is it negative? Positive. So my answer is positive. All right. So when they have the same sign, you add. When they have different signs, you subtract. All right. This is for addition. Let's look at the last one. Are these the same sign or are they different? They are different. This is a positive. This is a negative, right? And so I am going to take a 10 and I am going to subtract my 4. What is 10 minus 4? 6. I am going to go back to these. Which one has the larger absolute value? The 10, which is negative, meaning my answer is negative 6. All right? Another way to think of it is terms of money. If you cannot do positives and negatives, I can turn it to money and all of a sudden people understand. You have $4, you owe 10. How much do you owe now? You owe 6, right? And so O means negative. All right, so if they have the same sign, add, keep the sign. Different sign, subtract, keep the sign of the larger. All right? So let's there. For number 6, do these have the same sign or a different sign? Different. So I'm going to add or subtract. Subtract. So just subtract the smaller from the larger. 32 minus 13. Yeah, you're going to get 19. And because the 32 was larger, we applied that sign, which was positive. All right. Number 8, same sign or different sign? So am I going to add or subtract? Add. You should have 7 and 8 is 15. And because those were both negatives, it should be negative 15. Easy enough? All right. Let's look at decimals and fractions. So you do the same exact rules, but you have to remember your rules of decimals and fractions, okay? So decimals, my rule for adding and subtracting decimals is I line up the decimals, okay? Line them up. If you don't have enough of them, put zeros where you are missing the decimals, right? But the decimal places themselves must line up. Fractions, what's my rule for fractions? Yes, common denominators, right? I have to have common denominators. So let's look at the first one, A. For this one, do I have the same sign or different signs? Different. My 112 is negative, my 39 is positive. And so you are going to subtract these. 112.6 minus 39.27. All right? Now, I said line up the decimals. My top number is missing one, so I am going to fill in a 0 here. Fill in a 0. And then you're just going to subtract like you would, all right? You have to borrow, right, from the 6. So we're going to say 10 minus 7 is what? 3. 5 minus 2. I have to borrow again, right? Remembering our rules here. 12 minus 9. 3 and 10 minus 3 is 7, all right? So for this one, I have 73.33, right? Now, I need to go back to my original problem. Which one was larger, my positive or my negative? Negative. My negative was larger, so my answer should be negative. All right? Makes sense? All right, look at the next one. Same sign or different sign? Same sign. So I'm just going to add them. 2.39. 14.682. All right. I'm missing a decimal place. I need to add that decimal place up there. And then I'm just going to add them. They have the same sign. 0 and 2, 9 and 8, 6 and 4, right? 4 and 3, and 1. All right. 17.072. Go back to your original. What were your same signs? Negative. They were negative, so this answer has to be negative. All right? So you have to remember your rules of adding decimals. Line up your decimals, and then you're just adding numbers. just like you would, all right? Decimals aren't that hard. Pay attention to your signs. Same sign add, different sign subtract, and then always go back to your original to figure out what your answer will be as far as positive or negative goes. Let's look at our fractions. Everybody's favorite are fractions, right? 3/4 and 1/12. All right, they're my personal favorite. I would rather do these than decimals. So when I add fractions, my rule is I have to have a common denominator, all right? The easiest way to do this is to start with your biggest number, right? And say, what is in common starting with my biggest? Because my larger one usually can't go down unless you can reduce. So I'm starting with 12. Does 4 go into 12?
Yes.
It does. How many times? 3. And so that's what I'm going to multiply by, right? Top and bottom by 3. We're just getting a common denominator. Yep, so 9/12. I have 9/12 plus 1/12. Now, remember we're doing not just adding fractions, same sign or different sign here? Same. So I add, right. So remember with fractions, you just add straight across on the numerator. You don't touch the denominator, all right? Because the denominator you already found out is the same. So you're not going to make it 24. That doesn't make sense. You have 9/12 of something and 1/12 of something. You have 10/12 of something. And someone already said, with fractions, what do we need to do? Yeah, we need to simplify, reduce it, right? Yeah, and so we're going to say what goes into both 10 and to 12. 2 goes into 10 and to 12. So we're going to divide the top and the bottom by that 2, which will give us the 5/6. They were both positive when we started, so our answer will remain positive. Easy? Let's look at the last one, and then you're going to do a couple. So we have 3/32, negative 5/8. Same sign or different sign? Different. So we're going to subtract these, but we need a common denominator, all right? So yeah, 32. 8 does go into 32. All right, so we're going to leave this one. And then we're going to do this times what? How many times does 8 go into 32? 4 times. So this is actually going to be 20/32. So I'm subtracting these, right? So this guy is negative 20/32 and a positive. So I'm actually going to say 20/32 minus 3/32, right? Different signs I subtract. Yes? Just the smaller from the larger. I'm not worried about order right now because it's addition. All right? So I have 20 minus 3. What is 20 minus 3? 17. Yeah, it's 17, right? I don't touch my denominator. Now, can I reduce that? No. I cannot. Nothing goes into 17. Well, 17 is a prime number, so, I mean, if it's not 34 on bottom, it's not going to work. Now I go back to my original. Which of these was my larger absolute value? The 5/8 was, because when we got a common denominator, then we could easily see that was actually larger, right? So not until you get a common denominator can you always tell which fraction is larger. Once we got the common denominator, we saw, oh, negative 20 is obviously bigger than 3. Because my larger number was negative, my answer must also be negative. So this answer is going to be negative 17/32. All right? Questions? All right, so decimals, line them up. Fractions, get a common denominator. Decimals, you'll be able to tell right away which one's bigger because you're just looking at the whole number piece of it. But fractions, you may have to get the common denominator first. Go ahead and try some of these. All right, let's go over these. Number 16. Were these the same sign or were they different signs? Different. So I need to add or subtract here. Subtract. When you subtracted, you should have gotten 624.17. All right? Which one was larger? Your negative, right? So that's why my answer was negative here. All right, so line up your decimals. You should have done 624.4 minus, line up your decimal, 0.23. I was missing a 0, so I had to add a 0 there. Okay? And then you do your subtraction. What about number 18? Same sign or different? Different. So add or subtract here. Subtract. And I was nice and gave you a common denominator. So you just said 11 minus 4 is what? 7. And it was a negative, right? So negative 1, because you should have gotten negative 7 over 7, which is negative 1. All right. Let's look at some properties here. Now, these properties seem to kind of come out of nowhere, but there's a reason they're here. If everything is addition, then it doesn't matter what order you do it in, all right? This is important because if you get several numbers, then sometimes it's easier to throw certain numbers together, especially if you're talking positives and negatives. So as long as everything's addition, it doesn't matter what order it's in. It doesn't matter how you group it. If you add a 0, it's going to stay the same. And if you add two opposites, they will turn to 0. So if I have a positive 3 and a negative 3 and I'm adding them, my answer is going to be 0. That's what those are telling you. And so what this helps you do is change everything to addition, and then I can just group all my negatives together, group all my positives, and then just do one calculation at the end. All right? And so that's what these properties are telling you, that you can change the order as long as you have all addition. So if you turn the page and you see the next one, they have added some numbers here. We have multiple numbers that we're adding. They have negative 1 plus 5 plus a negative 3 plus a negative 7 plus 4 plus a negative 6. Now you could go straight across and just be like add, subtract, whatever. Or you can group because it's all addition. And so what you'll find is it's sometimes easier to say, well, let me do all of my negative numbers and all of my positive numbers. So if I start with my positive, I have a positive 5 and a positive 4. What is that going to give me? 9. And so I'm going to write, well, I have a positive 9. And then for my negatives, I have a negative 1, a negative 3, a negative 7, and a negative 6. Now I'm actually going to add this even a little differently. I'm going to say, well, negative 3 and negative 7 give me 10, right? Plus 1 plus 6 gives me 17. Those were all negatives, so I could just add them, and I know that I'm going to have plus a negative 17 here. Does that make sense? So I grouped all my positives and did that one, and then I grouped all my negatives and did that one. So now I have a positive 9 and a negative 17. So I have two numbers with different signs. What am I going to do? Subtract. 17 minus 9. What is 17 minus 9? It's 8, right? And then which one of these had the larger absolute value, my positive or my negative? My negative. So my answer is negative. All right? So grouping helps. When it's all addition, you can just throw all of them together instead of going back and forth, back and forth, back and forth. There's a lot more room for error when you just go across, all right, than there is if you just simply add your positives, add your negatives, and then do one calculation at the end. All right, let's look at the next one. For my positives, I have 8 and 15. What does that give me? 23. And I'm going to add to that my negatives. My negatives are negative 3 and negative 8. What is that going to be? Negative 11. Different signs. I am going to subtract. 23 minus 11 gives me what? 12, right? Which one was bigger, my positive or my negative? Positive. So my answer is positive. All right, so grouping makes it a little bit faster and a little less room for error. Add all your positives, add all your negatives, and then do your subtraction between the signs. So, all right, let's look at these. We're grouping our positives first. Positive 14, positive 6. What did you get? 20. We're adding it to our negatives. Negative 9, negative 28. Gives you what? Negative 27. Right? I mean 37. I heard 27. I said it wrong. Sorry. All right. Positive and negative. What am I going to do? Add or subtract? 37 minus 20. What do you get? Which was larger, my positive or negative? Negative. Right? So subtracting obviously is not commutative. We can't change the order. 5 minus 3 is not the same as 3 minus 5, right? But the definition of subtraction allows us to use our addition rules, because the definition of subtraction is adding the opposite, period. That's what it is. Subtraction is adding the opposite. If I said 5 minus 3, we all know that is 2, okay? That's very simple. 5 minus 3, that is 2. But let's apply our addition rules here. Adding the opposite means if I have 5 minus 3, that is the same thing as adding the opposite. 5 plus a negative 3. What do my rules say when I'm adding two numbers with different signs? Subtract and keep the sign of the larger absolute value, right? 5 minus 3 is 2. My 5 was bigger. It was a positive 2. So this works nicely when numbers, are really tiny. But then you start throwing in positives and negatives and negatives and negatives, and they just get all over the place. And so if you change it to addition, then you can just use your rules of addition, okay? So let's look at the first example here. Look at the example right below. They've given us 3 numbers here that they want us to subtract. All right? So the first one is 4 minus a negative 2. 4 minus a negative 2. All right? So we are going to apply the rule of adding the opposite. It is subtraction. The definition of subtraction is adding the opposite. So I'm going to make this 4 plus a positive 2. I changed this negative to a positive, and I changed this negative 2 to its opposite. Its opposite is positive 2. So now I can see that 4 minus a negative 2 is really the same thing as 4 plus 2, which is 6. And that is my answer. So subtraction is just adding the opposite, and you can change every subtraction problem to this. Now here's the thing. Some of my students want to take this all the way, and I'll give them an addition problem, and then they change it to an opposite. Don't change your additions. If it's already addition, just use your addition rules. If it is subtraction, change it to adding the opposite. And then you can use your addition rules. Next one, B. We have negative 3 minus 2. All right? Subtraction is what? Adding the opposite, right? So I'm going to add the opposite here. And now we can easily see that we have two numbers with the same sign. Same sign. So we're just going to add them. 3 plus 2 is what? 5. And both of those were negative, so that means my answer needs to be negative. All right? Easy. Let's look at the last one. We have 2 minus 5. All right? So we're going to change this to adding the opposite. Adding the opposite. Now you can see you have different signs. So if I have different signs, my rule for addition is what? Subtract and keep the sign of the larger. 5 minus 2 gives me what? 3, and it's negative because my negative was my larger absolute value. All right, so page 20. Try a couple of these, and then we're going to do some decimals and grouping. Page 20, numbers 2 and 6. Page 20, numbers 2 and 6. We have 4 minus 5. So we're going to change this to adding the opposite. Adding the opposite. We now have different signs, so we're going to subtract, right? 5 minus 4 is 1. My 5 was larger, so I'm going to get -1. All right? Look at the next one, 6. Subtraction is adding the opposite, right? So I'm going to add the opposite here, okay? So now I have 7 plus 3. Same sign. I'm just going to add. 7 plus 3 is what? 10. They're both positive, so my answer is positive. Questions on that? We good? This is where I start to have kids really mess up their positives and negatives when you throw lots of them at you at once. So what we're going to do is we're going to change all of our subtraction signs to addition. Now, one thing in Algebra 1, your lower maths, what they're nice about is they typically put your negative numbers in parentheses, right? And so we're going to go through here and we're actually going to change all of these to addition. So we're going to say we're going to change it to adding the opposite, okay? We have this absolute value of -3. We're going to leave that alone, right? Okay? And then we have minus a -4. We're going to change this to addition. So we're going to change this to adding the opposite, okay? And then we have a plus -2. That's already addition. Don't change it, okay? You can't change that to a +2 because it's already addition. So we're going to leave this one alone. Then we're adding a 9. This is already addition. We're not going to touch it, okay? We're only changing our subtractions so that we can use our addition rules, okay? Then we have a minus a -7, okay? So we're going to work inside out here, okay? Because this is brackets. So we're going to deal with this one first. We have a minus a negative here. So what are we going to do with that one? Change it to adding the opposite, right? Does that make sense? Well, then now we have a subtraction here. So right now, we have minus what we have said is a +7, right? What are we going to do? We're going to change it to adding the opposite. So this is actually going to become plus a -7, okay? So when you have 3 negatives butted up to each other, it goes back to negative, right? Because even negatives will be positive here when you're subtracting, and then odd ones will be negative. And it's the same rule for multiplication. Just pay attention to the order that you do it in, all right? Now, if you had done the other way, and if you had just done adding the opposite here, you could have just bothered with these two, and you could have left him a negative, whichever order you do it in, okay? All right? So now we're going to simplify these. I'm going to rewrite it. Absolute value of 3. How can I write that? What is the absolute value of -3? It's just 3. And then I have plus a +4. I'm just going to write that as plus 4. Okay? I have plus a -2. I'm right, plus a -2. Plus 9. Right? And now I have a plus -7. All right? Now it's all addition, right? At this point, I have all addition. So if I want to group them, I can. Remember how we grouped them from the first example with multiple numbers. All right, I can take my 3 plus my 4 plus my 9, right? 3 plus 4 is 7. 7 plus 9 is what? 16. And then I can group my negatives. -2 plus -7 gives me what? -9. And so from all of those numbers up there, I get 16 plus -9. 2 numbers with different signs that I'm adding. What am I going to do? Subtract and keep the sign of the larger. 16 minus 9 is what? 7. Which one had absolute value was bigger, the positive or the negative? Positive. Positive 7 is my answer. All right? Questions?